Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0420, indicates a problem with the catalyst system efficiency on a Honda Accord from 2008 to 2012. This code suggests that the catalytic converter is not meeting the efficiency standards established by the manufacturer, which can lead to increased emissions. The main components involved in this issue typically include the catalytic converter and the heated oxygen sensors, HO2s. The catalytic converter is located in the exhaust system, generally between the engine and the muffler. The HO2s sensors are placed both upstream and downstream of the catalytic converter, measuring the level of oxygen in the exhaust to determine its efficiency. If the readings between these sensors don't align as expected, it triggers the P0420 code. It's important to address this code promptly to ensure vehicle performance and compliance with environmental regulations. DTC P0420 points to an issue with the efficiency of the catalytic converter, a critical component of the exhaust system. The catalytic converter operates by converting harmful exhaust emissions into less harmful gases. Surrounding this converter are the oxygen sensors. The primary, or upstream sensor, HO2S1, which monitors the oxygen content prior to the converter, and the secondary, or downstream sensor, HO2S2, which gauges the output after the exhaust has passed through the catalyst. If the secondary sensor shows a significantly different reading compared to the first, it signals that the catalytic converter may be malfunctioning. The physical location of the catalytic converter is beneath the vehicle, attached to the exhaust system, while the HO2s sensors are installed in the exhaust pipes leading into and out of the converter. Addressing this error quickly is vital for maintaining your vehicle's efficiency and passing emissions tests. The potential causes of DTC P0420 can vary, but the most likely are a faulty catalytic converter, malfunctioning heated oxygen sensors, HO2s, or poor fuel quality. A faulty catalytic converter could result from age, wear, or contamination from fuel additives or engine oil. The HO2s sensors could also be malfunctioning, either due to wiring issues or sensor failure, leading to erroneous readings and triggering the code. Poor fuel quality can lead to incomplete combustion, which allows unburned fuel to enter the exhaust system and damage the catalytic converter. These issues should be evaluated in order of likelihood, because if multiple DTCs are present, they should be diagnosed prior to addressing P0420, as they might contribute to the problem. The symptoms associated with DTC P0420 can manifest in several ways. A noticeable decrease in engine performance is common, as the vehicle struggles to manage exhaust gases efficiently. Alongside this, fuel efficiency may suffer as the engine works harder to compensate for the inefficiencies caused by the faulty catalytic converter. The check engine light, CEL, will illuminate on the dashboard, providing the driver with a visible warning that something is amiss. In more severe cases, drivers may experience rough idling or stalling, especially during acceleration. It's essential to recognize these indicators early on and take action by conducting diagnostics to prevent further engine damage or heightened emissions. For the first step in troubleshooting DTC P0420, you'll want to start by turning the ignition switch to the on position, which is marked as 2. Before diving into the diagnostics, it's crucial to record all freeze data and onboard snapshots available. Freeze data provides a snapshot of the vehicle's operation at the time the code was triggered, capturing pertinent information such as vehicle speed, engine temperature, and other variables. Reviewing this data will give insight into the conditions that led to the P0420 error, helping narrow down potential causes. This initial assessment will set the foundation for the troubleshooting process, ensuring that no critical data is overlooked. In Step 2, clear the DTC using the Honda Diagnostic System, HDS. This system allows for a comprehensive diagnosis and troubleshooting of Honda vehicles. Once the DTC is cleared, start the engine and hold the engine speed at 3,000 RPM without load, which means the vehicle should be in park for automatic transmission or neutral for manual transmission. This step needs to be maintained until the radiator fan activates. Then, allow the vehicle to idle. Such actions help to reset system parameters, giving the catalytic converter an opportunity to function under normal operating conditions. This strategy may also provide more accurate readings on subsequent tests. For the third troubleshooting step, you'll need to test drive the vehicle under specified conditions. Start by checking that the engine coolant temperature, ECT sensor 1, is maintained above 158 degrees Fahrenheit, 70 degrees Celsius. The vehicle should be driven at speeds between 45 to 75 miles per hour, 72 to 120 kilometers per hour, for at least 5 minutes with the cruise control set. It's crucial to maintain these speeds because it helps to simulate normal driving conditions while allowing the exhaust and catalytic converter to function optimally. Additionally, you will want to decelerate while fully closing the throttle to observe the vehicle's reaction. Performing this test drive 3 times or more ensures that any intermittent issues are identified and sufficient data is collected for further analysis. In Step 4, you'll monitor the onboard diagnostic (OBD) status for DTC P0420 using the HDS. Depending on the results, if the HDS indicates that the system has failed, you'll proceed to the next step in the troubleshooting protocol. However, if the system indicates passed, it suggests that the issue might be intermittent or that the system is functioning properly at this time. If indicated as executing, it means you should keep driving the vehicle until a definitive result surfaces. If the HDS reads out of condition or not completed, return to the previous step and recheck the specified driving conditions. This step is crucial as it determines the migratory state of the error code. For the 5th step, turn the ignition switch to the lock position to ensure that all systems are properly shut down before making any replacements. The next action involves replacing the warm-up 3-way catalyst, WTWC, an integral component in managing emissions and providing a cleaner exhaust stream. A defective catalytic converter can lead to various emissions-related issues, including increasing harmful exhaust substances. It's essential to use OEM parts to ensure compatibility and effectiveness. After replacing the WTWC, the system should be set up to monitor its performance and efficiency again. In the 6th troubleshooting step, turn the ignition switch back to the on position in preparation for resetting the engine control module, ECM, or powertrain control module, PCM. This reset is crucial after replacing any major components, such as the catalytic converter, as it allows the system to recalibrate and relearn optimized operating conditions. Using the HDS, perform the reset for the ECM or PCM, which will erase any stored fault codes and prepare the system for a fresh start. Following the reset, the vehicle's management system and sensors adjust their functionality to align with the new component specifications, ensuring better performance and efficiency. Step 7 requires performing the idle learn procedure for the ECM or PCM after the reset. This procedure allows the system to learn the correct idle settings under the new component configuration, ensuring smooth running and optimal engine performance. The idle learn process typically involves letting the engine warm up to its operational temperature, followed by allowing the engine to idle without load for a certain period. Following this step, take the vehicle for a test drive for approximately 10 minutes while varying the speeds. This driving period allows all components to operate under different conditions, giving the ECM/PCM adequate time to adapt and monitor the vehicle's performance closely. In Step 8, check the CATA monitor condition using the HDS, as this will provide feedback on whether the catalytic converter is functioning within the designated parameters. You will reference the data list within the HDS to analyze the current condition of the catalytic converter. An OK condition indicates that the catalytic converter is now operating efficiently following the repairs and adjustments made. However, if the condition is noted as no, it means further investigation is required, and you will need to revert back to the previous step to conduct additional checks to identify residual issues which may have been overlooked. For the 9th troubleshooting step, you will need to test drive the vehicle again under previously specified conditions. This includes ensuring that the engine coolant temperature, ECT, is above 158 degrees Fahrenheit, 70 degrees Celsius, and maintaining vehicle speed between 55 to 75 miles per hour, 88 to 120 kilometers per hour, for 10 seconds before decelerating with the throttle closed completely. As before, it is important to repeat this driving pattern multiple times to establish a comprehensive performance check, allowing the ECM/PCM more opportunity to monitor the catalytic converter's efficiency consistently. Keeping track of these readings during the test drive is vital for accurate diagnostics. The final verification, after completing all previous steps, is to check for any pending or confirmed DTCs using the HDS. This process ensures that all systems are back to normal parameters after repairs and that no new issues have emerged. If the P0420 code or any other DTC does not reappear, it suggests that the repairs were successful and the vehicle is functioning correctly. It's imperative to leave the diagnostic equipment monitoring for a brief period, as intermittent issues may take time to manifest. Following this verification can provide peace of mind that the vehicle is fully operational and compliant with emission standards. Proper preventive maintenance plays a key role in avoiding issues like DTC P0420 in the future. One effective strategy is to consistently use high-quality fuel, as lower-grade options can lead to incomplete combustion and potentially damage the catalytic converter over time. Regular engine performance checks can help identify minor issues before they develop into major concerns. Keeping up with regular oil changes, ensuring your vehicle's air filters are clean, and following the manufacturer's recommended service intervals can greatly enhance the longevity of the catalytic converter and sensors. This proactive maintenance can save both time and money in the long run by averting significant repairs. In conclusion, DTC P0420 signifies an issue with the efficiency of the catalytic converter, an essential component in reducing vehicle emissions. The troubleshooting process involves a series of systematic checks and verifications, ensuring that all potential causes are evaluated. From the catalytic converter itself to the heated oxygen sensors and fuel quality. Understanding how these components work together is crucial for diagnosing and rectifying the problem effectively. In addition, implementing preventive maintenance strategies, such as using high-quality fuel and maintaining regular engine performance checks, can greatly reduce the risk of encountering similar issues in the future. By adhering to these guidelines, owners of Honda Accords can enjoy a smoother driving experience and contribute to better environmental health. Please like and subscribe to the channel. See you next time.